Hey Reid, you were asking a question from the motor's SO2 review. You were saying that the last few questions in that review talked about uh, rotor designs and starting inrush currents or torques, and you found them a bit tricky. So I just took one out of the last few that are in that review. This is question 42, and I'll go through so you see what you're looking at doing with questions like this. The question is, I have a three-phase 100 horsepower design C motor, so the rotor design is C. It has a full load amps or full load current of 125 amps. It is connected to an auto transformer reduced voltage starter that is set on the 80% taps. And what we want to know is what's the starting inrush current at the starter. And so to figure this out, if you look up in Module B, the different styles of rotors in Objective 4, you'll see that a Design C rotor normally has a starting current of 500% of the full load current. So normal inrush current for a Design C rotor is 500% of the full load amps. And that would be and 125 times 5 is 625 amps. So ordinarily, if this motor was not started on a reduced voltage starter, it would draw about 625 amps. Now, it is connected to an auto transformer that's set on the 80% taps. So, because it's set on the 80% taps, I'll just say so on the 80% tap of an auto transformer, if we're on the 80% tap of an auto transformer, it is going to reduce the current at the motor to 80% of what it would ordinarily be. So the I starting, I'll put I start for reduced voltage starting using this auto transformer reduced voltage starter at the motor is going to be full voltage starting current, I full voltage starting, times 80%. And it's going to equal the normal full voltage starting current, I think we said was 625 amps times 0.8 is 500 amps. So the starting current at the motor is going to be 500 amps instead of 625. But in the question, they're asking, what is the starting inrush current at the starter? And a way to kind of think of this is, if I kind of drew a real quick diagram of what it would look like. What the question is asking for is not what the current's reduced to at the motor, but what is the current reduced to on the line side of the starter itself. And auto transformer reduced voltage starters give us a second reduction on the line side because we have the 80% tap we're using, so we're using only 80% of the windings of that auto transformer to feed voltage to that motor. And we also have a transformer ratio where if the voltage goes up on this side of the auto transformer, then the current's going to go down going back to this side to keep the volt amps primary equal to the volt amps secondary of our auto transformer. And so we get a double reduction with this auto transformer reduced voltage starter, and the formula that we use to find the current on the line side is going to be I start reduced voltage starter on line side equals full voltage starting current times our percent tap, which is 80% squared, which is going to equal, I'll just push this up a little bit, which is going to equal 625 amps times 0.8 squared, which should be 400 amps. So that's what the starting current would be for this motor using an auto transformer reduced voltage starter set at the 80% tap. This is the current that the line side of this auto transformer would see, and the utility is definitely interested in this current because that's what they supply on the line side. So that's how a question like that is done. You need to be familiar with what each design motor, each design rotor we have, A, B, C, or D, will have different characteristics as far as starting current and starting torque. This should help you do those kinds of questions. Hope that helps.